Hi, and welcome with this video where I'm going to carry on explaining how do we use radians and what radians are. So again, let's remember what the problem with degrees is. If I have these equations that we were using, this comparison of proportions to calculate arcs and sectors, I had that the circumference was calculated by 2 pi r and the area of the circle was calculated by pi r squared, and I can therefore calculate length of an arc and area of a sector. Now, the problem, what I was pointing out, is that 2 pi r and 360 degrees both are representing the whole circle, and that we should simplify that somehow. Maybe I can put angles in terms of pi, and then things will simplify. I hope in this presentation you get to have an idea of exactly how that happens. So let's just think of a better way to understand angles and to measure angles in a more useful manner. So instead of using degrees, I'm going to try to use pi. So what we're going to do is it's very simple, think about it. I'm just going to define angles in terms of the perimeter. So here's how you do it. Well, take a circle, and we're going to take a circle, a very interesting circle, we're going to be talking about it a lot. A circle that has radius 1 unit. So what is the circumference of that thing? Well, the circumference, the perimeter, would be 2 pi times 1, so the whole circumference would be 2 pi. That makes sense, huh? The radius is 1, the whole circumference is 2 pi. Well, there you go. Now, suppose I start here, like in 0 degrees, no? You start over here, and you start moving up, and you go up degrees. Like if I was in degrees, it would be like 30 degrees, 60 degrees, 90 degrees. Here, and I'd be like 180 degrees, maybe somewhere here, something like 235 perhaps, 270, and back to 360, and I can actually carry on. I'd be like 450 degrees and so on. Now, imagine you're a dot here. If you're a dot here, you start traveling around, right? Rather, like if I'm here, how much have I traveled? Well, I've traveled this length here, which is how much? Well, it's a quarter of the perimeter, right? A quarter of this perimeter is how much I've traveled. And if I traveled the whole way around, how much have I traveled? Well, I've traveled 2 pi. So the length a dot travels when it goes 360 degrees around the radius one circle is 2 pi. Well, I can use that as my way of measuring angles. 2 pi would be my 360 degrees. Just visualize a dot that's moving around, and if it completes the whole circle, it's moved 2 pi, because that would be the perimeter of that circle, right? And I can use that rather than 360 degrees. So now we get a bunch of new measurements. For example, if 2 pi is 360 degrees, well, half of that would simply be pi, and a quarter of that would be pi halves. And each one of these is representing degrees. Now, don't get confused. Pi is 3.14159, etc. Doesn't mean that pi is 180, the number. 180 degrees does not mean 180, the number 180. It's talking 180 of one unit called 1 degree, which is a very small thing over here. Very small line, very small angle. This is a unit in itself, degrees. That's why we put the little 0 up here. Pi is still 3.14159, etc. Okay? So we can use this idea to measure angles. So 90 degrees, we can say it's pi halves. And it will actually be a lot more useful. Well, in a minute, I'll show you how. First, let me give you a bunch of important angles measured in radians. So, for example, pi halves, we saw it as 90 degrees. Pi thirds would be 60. And pi sixths would be 30. And here you have a bunch of them, equivalents. Now, rather than trying to memorize these, I strongly advise that you simply think that 2 pi is 360, and then if you want to calculate something else, again, you can do a regla de tres, or simply divide the proportions. So, that like 180 divided by 360 must give you the same as pi divided by 2 pi. Basically calculate proportions, and you will be able to calculate whatever you need in radians or degrees. Let's see what the impact this has on our initial problem is. So I had these equations here. This was 2 pi r, this was pi r squared, and I was trying to simplify them. And you see, if I was measuring the angle in degrees, I was getting this. This angle here, this alpha angle, is represented in degrees, then I have to divide by 360. But if this angle is representing in radians, here's what happens. Well, rather than having 360, I would have 2 pi, because that's what 360 is in radians, right? And now this cancels out beautifully. And here the pi goes with the pi.